This Zoom session is being brought to you by the Fractal Dust Labyrinth C. Okay, for today we do sections 5.1 and 5.2, having finished chapter 4 last time. So chapter 4 homework is due by the end of this week. Anyhow, 5.1 is about exponents, 5.2 is about scientific notation. An exponent, well, we have x to the power n. This x here is the base, this n is the exponent known as the power. You find this by starting with 1 and then multiplying by x n times in a row. So x to the first is just x to the second is x times x, called x squared, because if you have a square with side x, its area is x to the second power. X to the third power is x times x times x, called x cubed, because a cube with side x has volume x to the third power. X to the fourth is xxxx. I suppose you could call it x tesseracted if you were into science fiction, and so on. X to the second times x to the third, well, it's 2x's times 3x's. It makes x to the fifth power, and 5 is 2 plus 3. So x to the second times x to the third equals x to the 2 plus 3. In general, if you multiply two powers of x's, you add the powers. X to the a times x to the b is x to the power a times b. Now, if instead of taking x squared times x cubed, we take x squared and cubed that, that'd be x squared times x squared times x squared. You add the exponents, 2 plus 2 plus 2 makes 6. You get 6 by multiplying 2 times 3. And in general, x to the a, that to the power b is x to the power a times b. If we had a product and squared that, xy all squared is xy times xy. That's 2x's times 2y's, x squared times y squared. And in general, a power of a product is a product of the same powers. Xy to the power a equals x to the a times y to the a. So powers, exponents, distribute over multiplication. It's much the same way that multiplication distributes over addition. If you have a fraction, x over y, a ratio, and square that, that's x over y times x over y. That's xx over yy is x squared over y squared. And in general, a power of a ratio is a ratio of powers. X over y to the a is x to the a over y to the a. So powers distribute over division in much the same way multiplication distributes over subtraction. Now, if we have x to the n, you can rewrite it as x to the n minus 1 times x, or in other words, x to the n divided by x is x to the n minus 1. This is a way of taking a minus 1, subtracting 1 from a power of x. Now, use this to define x to the 0 and x to negative powers. X to the 0 is x to the 1 minus 1. That's x over x, which is 1. X to the 0 is 1. You can see that if we went back to here. X to the n is 1 times x n times. So x to the 0 is just a 1, no multiplication, and therefore just the 1. All right. X to the negative 1 is x to the 0 minus 1. So x to the 0 over x, which is 1 over x. X to the negative 2 is x to the negative 1 minus 1, which is x to the negative 1 over x, which is 1 over x, again divided by x, is 1 over x squared. So x to the 0 is 1, and in general, x to a negative power is 1 over x to the positive power. All right. Now, if we had 1 over x to a negative power, that's x to a positive power. So 1 over x to the negative 3 is x to the third. And if you have a ratio of negative powers, then you can swap them. X to the negative m over y to the negative n equals y to the n, goes into the numerator, over x to the m, that goes into the denominator. Now, if you have, for example, if you have x squared over x to the fifth, what is that? Well, 2x's divided by 5x's, that's 1 over 3x's, that's 1 over x to the third. That's x to the negative third from here. And you get negative 3 from a 2 minus 5. There's that. X to the second over x to the second, that's just 1, which is x to the 0. And 0 is 2 minus 2. Again, we're subtracting powers. X to the 5 over x to the 2, that's 5x's over 2x's. 2 cancel numerator and denominator, leaves 3 x's, x to the third, and we get 3 from 5 minus 2. In each of these cases, we subtracted the powers. X to the 2 minus 5 here, x to the 2 minus 2 here, x to the 5 minus 2 here. In general, x to the a divided by x to the b is x to a power a minus b. So if you put these together, these are this rule. Power product is product of powers. Is a power is a sum of the powers. Excuse me. And excuse me. Repeated powers, x to the a to the b is x to the a times b. Xy to the a is x to the a, y to the a. X over y all to the a is x to the a over y to the a. And x to a 0 is 1. X to a negative power is reciprocal of x to the power. And x to a ratio of powers is x to the difference of powers. So we do some examples. Y cubed, y to the 7th times y squared. Okay, these are products of powers, so we add the powers. 3 plus 7 plus 2. That's y to the 12th power. Now for this one, we have to watch out. A cubed, b to the 4th. These a and b, they have nothing up in the exponents, but that's not 0, it's 1. A equals a to the 1st, not a to the 0. B equals b to the 1st. So, okay. So a to the 1 plus 3 here, b to the 1 plus 4 here. It's a to the 4th, b to the 5th. This is a common error. When people see this, they just think, oh, there's nothing on there. Well, no, it's really an invisible one. A equals a to the 1st. Here's g to the 4th to the 5th times g to the 2nd to the 6th. Okay, here we have a repeated power, so we multiply the powers. Here we have a repeated exponent, so we multiply the powers. G to the 4 times 5 times g to the 2 times 6. This is a 20, this is a 12, g to the 20, g to the 12th. Product of powers, you add the powers. G to the power 20 plus 12, that's g to the 32nd power. Here we have x to the 5th y, all to a 4th power. We distribute the 4th power over each of these factors. X to the 5th to the 4th times y to the 4th. X to the 5th to the 4th, you multiply the powers and get x to the 20 times y to the 4th. Here we have m to the 3rd, n to the 2nd over 6m, n to the 11th. Now again, this m is m to the 1st in disguise, so we write it that way. 1/6, m to the 3 over m to the 1, n to the 2 over n to the 11. You take these powers, 3 minus 1. Here's 2 minus 11 here for the n. So 1/6 m to the 2nd, n to the negative 9. Now a negative power, n to the negative 9, means a positive, n to a positive 9 in the denominator. So we rewrite this as m to the 2nd, 6n to the 9th. Many of the problems in the book ask you to end up with everything in positive powers, if need be, in denominators. Here we have a really messy one. X to the negative 5 over 2, x to the 2nd, all to the negative 4th. All that times x to the 7th over x to the negative 8th, all that cubed. Okay, now this ratio, we take a difference, negative 5 minus 2 here. X to the negative 5 minus 2, all to a negative 4th. Here again, we take a difference of powers. X to the 7 minus negative 8, all to the 3rd. All right, so this is an x to the negative 7th to the negative 4th. This is x to the 15th cubed. Multiply the powers, set negative 7 times negative 4 here, 15 times 3 here. This is x to the 28th times x to the 45th. And then we add the powers. 28 plus 45 is 73. So x to the power 73. Here, okay, this is just a lot of mess. Here we go. Negative 3, c, d squared, all cubed, times c to the negative 1, d to the negative 3 cubed. All that divided by c cubed d to the 5th. Oh boy. All right, here we distribute the 3rd power over all of these factors, this 3rd power over these 2 factors, this 5th power over these 2 factors. So you get negative 3 cubed times c cubed times d squared cubed times c to the negative 1 cubed times d to the negative 3 cubed over c cubed to the fifth, d to the fifth. All right, negative 3 cubed is a negative 27. Here's a c cubed. D to the second to the third, you multiply the 2 times 3 and get d to the sixth. C to the negative 1 cubed, you multiply negative 1 and 3 to get c to the negative 3. D to the negative 3 cubed, you multiply negative 3 and 3 and get d to the negative 9. Here, c to the third, fifth, multiply the powers and get c to the 15th and d to the fifth. Okay. Well, all right, let's combine things. C cubed times c to the negative 3, c to the 3 minus 3, d to the 6, d to the negative 9 is d to the 6 minus 9. So you get negative 27, c to the 0, d to the negative 3 over c to the 15th, d to the 5. Now we take, oh, well, forget the c to the 0. That's just this 1, so we ignore it. D to the negative 3 in the numerator equals d to the third in the denominator. So you have negative 7 over c to the 15th, and then here we add the exponents, 5 times 3, 5 plus 3, excuse me. So you get negative 27 over c to the 15th, d to the 8th. Answer is this. Now here they have what the book called look-alike problems. Similar things. 8xy to the negative 2, 8xy whole thing to the negative 2, minus 8 to the negative 2xy. Okay. Slightly different phrasing, different results. Here, y to the negative 2 shows up in the denominator, so it's 8x over y to the 2. Here we have a whole thing to a negative second power, so it's 1 over the thing to a second power. Distribute the second power, 8 squared, x squared, y squared, under 1. Therefore, 1 over 64 x squared y squared for this. For this, minus 8 to the negative 2xy. Well, 8 to the negative 2 just shows up in the denominator as 8 squared. Underneath a minus xy. So you get minus xy over 64.